My wife's going to shoot us because she made sandwiches and we're standing there here talking. Anyway, so there's our grid connection. Then we have our generator connection. You'll notice that the generator connection is much smaller. It's not as big a connection. It's not a 50 amp connection. It's a 30 amp connection at 240 volts. So you could do the math. A 30 amp connection at 240 volts is going to be around 7 kilowatts. We have a 6.6 kilowatt generator. What's unique about this generator, yes, it is a fossil fuel generator, but what's unique about this generator is it's an inverter generator, and that's a whole other topic. It's not a constant RPM generator. Its RPM is going to change. It's going to produce power through an inverter. And this little green plug here is going to allow us to connect a control circuit between the generator. It's something I've yet to do. And connect it into the appropriate terminals that we looked at earlier, that are the control terminals for the inverter. And so with some parameters, not really programming because we're not writing code, we're going to go into menus, we're going to enter parameters, which will allow us to call on this generator to start when we reach a certain charge state for the batteries. Not a voltage state, but a charge state. You'll learn that it's very difficult to determine from voltage the state of charge for an LFP battery. But based on the state of charge for the batteries, we may call on the generator. We may never call on the generator. I mean, it's possible that we have enough energy from solar. It's possible that we have a grid connection and we draw our power from the grid. We can even set up priority. We can say our priority for power would be solar first. If solar is not enough to charge the battery, we want to call on the generator. And if the generator can't supply the power that we need, we're going to call on the grid. But we could change. What? Yes, we're coming. We could change the sequence so that, and again, this is programming, we could say we want solar priority. If solar's not enough, we could go to the grid.
Grid, right.
And then the generator. So those priorities will be established for us based on our intended use.
Is there a case where if you don't prioritize the generator and it doesn't run for a long period of time, the generator gets damaged? Do you have to, like, there's a periodic with the backup generator the bishops have, it periodically turns itself on.
Yeah, so that's another parameter that we'll set in. So I believe the default setting on a solar converter is every Monday. I don't know if it's 8 a.m. or 9 a.m. it's going to start. And it's going to run the generator for a period of time, which would allow the generator to charge its own battery, so it always has charging power. Because power doesn't flow through this cable into the battery of the inverter, of the generator itself. The generator has to charge its own battery.
So you don't have a pull cord because this is automatic.
But this generator is unique in that it's a portable generator, but it doesn't have a remote start. You can buy those on Amazon, you can buy those at Home Depot. It has an auto start, so it means it can be controlled, and there's intelligence in here. So there's a microprocessor in the generator, because some programming has to be in place. Unlike a generator that has a remote start, this device, this inverter, doesn't know if this generator is out of fuel. And the last thing we would want it to do is just keep trying to turn it over and start if it was out of fuel, because we would damage the starter in the generator. So the generator is going to have logic in it that's going to say, you can attempt to start me for this many seconds on one attempt. And then it would have a pause. And then it would say, we're going to give you this many seconds on the second attempt.
Mm-hmm.
And then it may even shut you out so that you don't get a fifth and a sixth and a seventh attempt, because you wouldn't want to do that. Something's wrong, right?
Mm-hmm.
And then the inverter has to have sufficient intelligence to say, stop trying, okay?
Mm-hmm.
So that intelligence, you're not going to get in my little Honda 3000 EU generator that's sitting in my garage. It's a lovely generator, costs $2,000, used to cost $3,000 for a 3 kilowatt generator. It's one of the best you can buy, but it doesn't have this kind of capability.
So that means the choke is automatic too. You don't even touch the choke.
That's correct. The choke is automatic. Like if I try to start this generator now, it's in the run position now, so I have fuel. It probably isn't going to start. Well, it did start because I started it the other day. The choke was off. It shouldn't have started, so it probably wants some level of choke. There's a solenoid behind here that's going to energize the choke when it's in automatic mode. Okay. And you notice how generators are noisy, and you notice how generators emit?
Pollution.
Anytime we combust fossil fuels, we're going to emit something, right? So we're going to emit some kind of hydrocarbon-related emission. So I used to say NOx, like nitrogen oxides and CO2 and a bunch of things. But someone always gets upset. So rather than say those things today, I just say, if you burn fossil fuels, something that isn't desirable is coming out the back. And if you don't believe me, just take a hose, connect it up to the exhaust, stick it in your car window, climb in there, and then tell me that it won't bother you.
With a suicide note.
And I'll watch you as you pass out. And trust me, I'll take you out and you'll recover and we'll make sure that you're okay. But, you know, our solution, mankind's solution to burning fossil fuels is dilution. But at some point in time, the dilution doesn't work anymore. Right? So,
Although to be fair, we can, ultimately, this could be run on clean biogas.
it could be run on cleaner fuels.
Yeah.
So,
Really?
but we can also change the operating characteristics of the generator. So for example, if you were camping and you didn't have a power station and you had a generator and you used electrical power and you didn't have an energy storage device, this has to run all the time. And this happens to be about a 7 kilowatt generator, but your average consumption might be half a kilowatt. So it's running very inefficiently. So one of the things that we can do, regardless of whether this is a dirty generator, a clean generator, or something in between, one of the things we can do is to make sure that it's running efficiently. So we find, where is the sweet spot in this generator? At what load would this generator produce the least amount of emissions per kilowatt hour generated? Well, we need to find that. We need to find where that is. So that load might be 80% of its rated load. What we're going to do then is we're going to program the load in the generator to draw that 80%. So instead of this generator running 24 hours at fractional load, very inefficiently, polluting the environment, we're going to have less pollution because we're going to run it where it runs very efficiently, the lowest emissions per kilowatt hour of power generated. We're going to run it for 2 hours potentially instead of 24
Charge the
hours.
batteries, and that becomes like a hybrid,
And now the
old
energy
diesel-electric hybrid thing.
Correct. The energy storage device is providing that buffer for us, okay? And we're managing the pulmonary system of our electrical system, of our energy system, which is the batteries, and we're making sure that we're keeping the battery where the battery is the most healthy, okay? And we're cycling this generator accordingly. And we're running everything as efficiently as we can. Now, yes, we're still burning fossil fuels. But if you're going to burn the fossil fuels, wouldn't it be wonderful to create the most possible amount of power with the least amount of emissions, regardless of the generator that you have?
Right.
Right?
Now this is putting out 120 here. It's not putting out the 240. We'd never put the RV onto here. We certainly wouldn't put the plastic shredder or any other tools that we're running on 240 into here. Where does that come out?
So this is an input we said before,
Right.
but that's kind of a incorrect statement, because remember, this is a grid-tied system, so we
Right.
can export power. So there's flows in both direction of power here. There's flows only in one direction here. So that we never send energy back to the generator. The generator's going to send energy one way when it's called a grid. The only loads that we can power are in this. Now this could have been an electrical panel. In a pure sense, it is an electrical panel. So here's our 50 amp, 240 volt plug for the RV. Now keep in mind, we can't supply
The 50 amps, right?
the 50 amps at 240, or
Right.
can we?
Well, depends on the load. Depends on what we're running on the inside. You keep the pipe big, but you're drawing less from it, right?
Yes and more.
Oh.
So yes and more. So
Oh, because we can go through the grid to get there.
Right.
Ah, okay.
So if we just put a 5 kilowatt system here and you are connected to the grid, there's a potential problem. My wires would have been undersized.
Yeah.
We could have actually pulled 50 amps or 12 kilowatts through the system, and we would have started to do some harm to the wiring system, because your RV will try to pull the 12 kilowatts, the supply is more than happy to supply the 12 kilowatts.
Right. The ins
But
between.
we have an interconnection which would not have been 12 kilowatts, and we would have had a problem. So we can, what's called bypass power, we can bypass the inverter when we're grid connected and feed the full draw of your RV. So the only time that you don't have this 12 kilowatt capacity is if you're not grid connected.
Right.
Okay, so we have an AC bus where everything is combined. The inverter output goes to the same AC bus as the grid input, as the generator input. These two can't be connected at the same time because you can't have the grid backfeed the generator. But any two of these can be paralleled. So the inverter output can be paralleled with the generator. The inverter output can be paralleled with the grid. Okay.
Well, so we shouldn't have them both connected.
That don't worry about it because that's all taken
Care by the
care of
programming in the
internally
inverter.
by the programming
Okay.
in the inverter.
Okay.
Okay.
So they stay connected physically, but you're letting the
So-
inverter do the disconnection.
So the wonderful thing about this is we can have your RV connected at 12 kilowatts when we're connected to the grid, which is the normal what we'd want to
Yeah.
have, because we want to be exporting power when we're producing surplus and importing power when we're not. We would want to have a secondary array that would plug in here that would offset all of your power, but timing is everything. We literally could have that array, a huge array, plug it in one day and offset all of the energy you would use all year.
Right.
But that's unlikely. So what we're going to do is size an array to offset the kilowatt hour usage that you would have annually, okay? But that doesn't mean that sometimes we're not exporting and sometimes we're importing.
Right. In fact, we do whenever we go away, we want to be exporting.
And now you can have the full draw for your RV at 12 kilowatts. And if the grid did fail, you can have the 5 kilowatt capacity of your backup inverter. It's always there for you.
And what about the generator says does 7 kilowatts? You wouldn't be able to you wouldn't draw 7 off of the generator if it was running, or would you?
At the present time, the solar converters, and I've queried their engineers, and they're working on it, but they don't have it yet. They don't have the capability to start the generator on a load condition, which would be wonderful.
Yeah.
I mean, imagine what you just suggested would be a wonderful thing if we have a 5 kilowatt generator and we start to draw 4.5. If we could program a threshold that said at 4 kilowatts of load, start the generator. So we'd have a parallel source of energy, right? So that we could go beyond the 5 kilowatts of the solar converter. We can't do that yet.
Okay.
But I suspect that
Well, you're creating the field. You're actually creating a demand for this. Yeah, driving
the need for it, right?
Yeah.
We're driving the need for it. So right now what you do have is you have Gfci outlets. Gfci is very different than breakers.
Yeah.
Ground fault circuit interrupters are there to protect you. Breakers are there to protect equipment. So if you ever think that a 15 or a 20 amp breaker is going to protect you from getting electrocuted, then you went to the wrong school. Okay, the breakers are there to trip on an overcurrent condition.
Right, you can still get shocked.
GFCR breakers are there to trip when there's an imbalance between the energy that was sent to the load and the energy that returns. Okay.
Right. So if there was moisture or something that created an earth path or a path through you,
parallel path through you, it's going to detect that because there'll be a differential between the energy that came in on the hot and returned on the neutral, and it's going to trip. And that's a human protection device. You'll find GFCI breakers in your kitchen and your bathroom, typically places where you might be wet. Okay, so we have a GFCI we could plug in here, or we could plug our RV connection in here, and of course from this RV connection you'd have a load center in your RV, and you have lots of 110 plugs, and you may have USB plugs in your RV, and you may have DC circuits in your RV, and you probably have a battery charger to charge the batteries there that are lead acid or whatever they might be.
That's right.
So we haven't changed anything. If you think about power station in its simplest form, rather than taking your RV and plugging it into a receptacle, we want your RV to be plugged into our AC output, okay? And now we take full command and we get all the benefits of the power station and what it's doing. We have backup power. We have peak shaving ability. We have...
you know that this is going to end up being in the design of an RV eventually.
I think so. I hope so. I mean, I have stopped and talked to some RV dealerships. And of course, their procurement is all at some corporate office in Wisconsin or Milwaukee or wherever the heck it is, California. And so they're not very good at making independent decisions.
Sure.
But I think we're going to see some inroads in family-owned, privately owned RVs, where we're going to go into a family-owned RV, like maybe Halet RV that's up in Michigan, and say, you know, we're going to provide you with something exclusively for a period of a year so you can make some inroads. And only your customers are going to have access to this technology. And for that, we need your investment to take a unit or two, put it on your floor, demonstrate it to your customers, and we'll satisfy that demand for you. And of course, there's negotiation costs and supply and all those things. And of course, there's concerns about how do you protect this technology, right? Because there's nothing in here that we're patenting.
Right.
So what we're really doing is we're integrating available technologies today to aggregate those technologies to make something that's superior to what's available today. So there's nothing that prevents anyone from copying what we're doing. Okay?
Right.
And I look at that as that's kind of good.
Yeah, well, it opens business opportunities.
Because our core business is building renewable energy systems for the ag sector. This is not that. So this is supplemental for us, but I think it's badly needed. I think the University of South Florida has recognized it as badly needed. The Patel Center has...
Well, and that's why our next project is the Student Green Energy Fund proposal that we're doing with George Philippidis and the students to take this to the next level, whatever we envision that to be. So it's not maybe on a little trailer, but it's in a weather-contained trailer that can be brought to disaster sites and run machinery and shredders and grinders and tools and everything that you've talked about, provide emergency power. So this is that bridge, and power maybe the mobile unit where people live or on site doing FEMA work, and that's what you've already started doing, right?
On that thought,
yep.
Thank you.
Wonderful. Thank you very much.
Thank you.
So we're so what I want you to do while we go grab a bite is think about, is this what we want? Okay.
Nah, let's go back to fossil fuels.
Well,
Come on.
but I meant literally
Is this configuration?
Is this the configuration that you want? Because once I tear it down and I paint it, I don't want to be drilling new holes in it.
Right.
It's all
Well,
done.
so as I understand, so this would be parked out in front of the bee house, or maybe out in the field on the other side of the RV.
Get this in the sun.
Right. Get this in the sun. We've got to get this to that outlet that the RV is currently plugged into. So this may have to be longer.
We have to get this into a grid connection. Well,
Or we have to run something.
Because right now I picked 25 feet to get in our budget.
Yeah.
But you can't really go over 50 feet because a 50 amp cable, this is number 6 wire, you're going to exceed the capacity of the wire to carry the electricity.
So it looks like we need to put another receptacle somewhere.
Maybe.
Because they just all connected together.
You could literally plug this into the receptacle that you plugged into today if you can get this in the sun somewhere.
Which we probably won't be able to. We're 100 feet away to get to the sun from
now,
that.
If your loads are mobile, like your shredder, you know, you'll notice that these two wagons are coupled. Now, this wagon was designed as a passenger vehicle. That's why it's so low and it's so wide. If we were designing a wagon for a shredder, which is a heavy piece of equipment, we'd want to think about what elevation is that piece of equipment fed at, what restrictions do we want to place around it so people can't access the dangerous components in it, what elevation does it have to be at so that we can service it. There would be a whole different thought process as opposed to let's create a wide platform that's low to the ground, that's extended well beyond the wheel well so kids can't get their feet stuck underneath it. And it may have a different capacity. It may be completely different look. In fact, I guarantee you, if we started out making this wagon to house a shredder, we wouldn't have done this at all.
Right. But I'm glad that we have this, like this for that.
I did send you an email.
Yeah.
And if you've got a manual or something, maybe if we shifted everything over, one of the things I was thinking of, can the shredder fit on this trailer?
Maybe.
Because we've got about 12 inches here, we got another 6 inches here, we got 2 or 3 inches up there.
Right.
So do we have enough room in 20 inches, roughly the size of this generator, to fit the shredder? And maybe the answer is yes, maybe the answer is no, but do we want to do that?
Right.
Or would it be better having a second platform?
Yeah.
And do we want to tear this all down, and lose the ability to.
No, we don't. We
Or
definitely
should we
want to have
start
it.
over
We
and
start
create a
over.
different-
We'd create something else for
Yeah.
it.
If you had like a box right here and just put it right here.
Very heavy.
Then access,
really?
the access
Yeah.
to it's tough, you know,
Yeah.
right? I mean,
That wouldn't
even
work.
the generator. What if we've got to get access to the generator?
No, and I think having them separate, so you have an experience where you have your mobile power generation solution, you have your passenger that can be hooked, and having a smaller thing that is just for a grinder and a shredder, that would make the most sense. So that if you could leave it behind, if you're not doing that, function, you don't bring it all out there, right?
So, I mean, for our trial coming up in a week or two, we could put the shredder on.
Yeah, just for dog and pony.
And we could put it here, but I really want everyone to be thinking about safety.
Yeah.
There's a lot of things that went into building this, okay? I mean, making sure the generator can't fall off the trailer, making sure that the height of this is such that we can fit it in. There's half an inch
A
of clearance
garage, right?
to go in my 7-foot
Yeah,
garage.
right.
And yet that sets this height, so let's not create a situation where a tall person, I'm between 6 and 6'1", I've got a little bit of room. I've set this so we have about 6'6" in clearance. But the first time someone who's 6'7" comes along here and bangs his head into the edge of this steel, this aluminum extrusion,
Yeah, it's good that you have that little
we're
cap
gonna
on
have
there.
a problem, right? So everything's
Very
a
well
compromise.
thought out, yeah,
You know,
for sure.
everything's a compromise. I mean, even how strong this was. The first time we brought this trailer to Rosebud, this was sitting at 8 feet because of code. We banged it into the aluminum siding and we
Cracked
broke
it.
these legs right off. So now I put heavier bolts down in here. They're galvanized lag bolts.
How is this going to travel on highway?
Support. It doesn't go on the highway. These aren't.
How are you going to get it? They're back roads?
The only way that this can go on the highway is if you put this wagon on a trailer, which is what I do.
Oh, okay.
So I put this wagon on this trailer, and then I transport it, right? So it goes up the little ramp that folds down in the back.
On this trailer? Oh, you have to take all that stuff off?
Yeah. So for me to get that to Rosebud, I've got to take my toolboxes off, and
Mhm.
we'll roll the wagon up. In fact, I might use you guys before you go home today,
Mhm.
so we can load up that other wagon
Yep.
and get it on there. And
So all this comes off, the wood here comes off the sides, all this stuff.
no, it'll stay there. The
It
wagon,
will?
oh yeah, the wagon,
Yeah.
the wide wagon,
Yeah.
the narrow wagon fits, but the wide wagon won't.
Yeah,
The narrow wagon would be too tall for that, so we'll have to take the
take that off.
yeah.
But then what about the winds? Is it,
The wind's not going to be a problem
okay.
because we actually built one earlier on here. So what we
Yeah.
haven't talked about, there's so many things we could talk about. So for a month, I had put, this was taller before. I've broken it down. You can see where I've disassembled
Mhm.
some parts because of the paint is absent. This used to be the same height as that.
Mhm.
And we had the same modules up on this. And I drove around for a month at highway speed, 70 miles an hour. And we never had a problem with it. But what we did find is over a period of time, everything started to loosen up.
Yeah.
Okay, so we're not going to have to fight 70-mile-an-hour winds pulling it behind your golf cart on Rosebud.
Right, right.
So it was a pretty challenging
Yeah.
test. And then I took that same rack, I took it apart, we put the modules over there, and I lowered this so I could transport kayaks and canoes that my wife
Mhm.
used, so that we just didn't throw all this lumber away. And you'll notice that this whole thing just sits in pockets.
Yeah.
So we can
Good.
literally lift this off. The whole thing will lift off, and we can roll the wagon up on top. It sounds easy. It's not very easy. The wagon's not light. But
And I
it
asked
does
because
roll on top.
when Todd was bringing the solar cart back to Rosebud, the panels flew off it, and one of them smashed and is ruined.
Oh, let's look at something. We didn't talk about this. And by the way, my wife's really going to shoot me now. We found it an hour ago. But so what I've done here is I've used the same L feet that we would use on a roof that are listed for hurricanes here in Florida. And I've bolted with stainless steel bolts into standard rails, okay? So we've made this connection. But if this were to vibrate
Right.
loose or come undone, this rail would have dropped because it would have just fallen
Oh,
down.
yeah.
So what we did in addition to this is we put this plate
Mm-hmm.
underneath,
Uh-huh.
and that was the first. So step one was create a plate underneath that provided secondary support for the rail in case this bolt loosened. These T-bolts they're called, loosened. so that there was secondary support for that. But then nothing would have prevented, if we lost multiple bolts, from this whole thing sliding
Yeah.
and falling off and then damaging our expensive generator. So then what we did is we just flipped over a L-foot, and this L-foot is drilled into this plate, and now this can't slide
Can't
off
slide.
anymore
Yeah.
because it's held in with this L-foot that's inverted. So this piece provides tertiary support, this is secondary support, and there's our primary support.
Okay.
And I suspect we'll still have problems. So, I mean, everything that we've
Drive
done,
slowly.
everything we've done is some attempt to make the system safer. You know, there may be times when you want to have this service, you might drive it into the garage, and now it fits into the garage. We even recycled these caps.
Yeah, nice. So it's not
these are how
sharp.
they were shipped, so that someone, if we
Yeah.
do get that tall fellow who's 6'7", that he doesn't really injure himself. So he's going to have a sore head, but it won't be that sharp corner.
Beautiful.
And one thing we didn't talk about, what we had talked about before we started shooting the video, one of the things we found on the first and second generation batteries is we had to lock the batteries down. We had to clamp them into place.
Right.
And they were just sitting on metal.
Yeah.
What we've done is we've used the
Use the
same packing
yeah.
material, the styrofoam, and we've left the batteries sit in that styrofoam.
Yeah, that vibration
So that
control.
we get some vibration isolation, we get some impact isolation, and it's the box's size. I'd like to say I planned this, but it was not really that way. We bought the box, and then we went hunting for batteries that we could fit 4 batteries in.
Isn't that
And
something?
there were not a lot of batteries.
Is it?
EG4s are we got these out of Texas, I believe.
That's
nice
beautiful.
family-run business that's selling these batteries. They're manufactured in Asia. Of course, they're not going to tell you where they're manufactured, but you can guess. But they had the best specification at the best price point we could find. If we were to buy at street price, 1,000 kilowatt hour energy storage, today street price is probably around $1,000 per kilowatt hour. So we're about a third of that with these batteries.
Wow.
And I believe these batteries are superior to a lot of the product that you would buy at $1,000 per kilowatt hour. So we're actually less than a third. And we've got a LFP battery with a BMS, with some temperature protection, some water resistance because they're IP67 or IP68, I'm not sure which one it is. So they're marine grade batteries, and I'm pretty happy with the solution.
Is this box supposed to be airtight, moisture tight? No, it's supposed to vent a little bit, right?
This is a job site box. If
Yeah.
we were to buy a NEMA enclosure for this, like a NEMA 3R enclosure, I mean,
Crazy
I
expensive.
think this box is selling. If you went to Simplify's website, for example, the cabinet that they house their 3.8 kilowatt hour batteries in, and I think they can house up to 4, maybe 6 3.8 kilowatt hour batteries. So they have in their cabinet, they have about the same storage capacity as we have. I believe those cabinets are between $2,000 and $3,000, just the cabinet.
Right. So what do we do for moisture control?
Well, we don't care because everything in this,
And this is outdoor.
rated,
Okay, there you go.
right?
That's what I
So
mean.
you could literally set these outside. The box is more for security and physical protection.
Okay.
Right. We may need to ventilate these. Solarc wants a minimum of 6 inches between this edge and this edge. Okay, they want 6 inches of clearance. We're a little bit shy. And we may find that we have to ventilate this, but that's just one more step that we do. And it would only be triggered by the fact that we can't control the temperature.
Right, because it gets too hot
One of the
inside.
reasons we've selected a white finish
Yeah, to keep the bounce.
to keep the radiative gain on this box as low as possible. Now we're going to add a bunch of stickers and labels that aren't going to help, but it's as good as it gets. And you'll notice that all the ventilation fans for the Solarc are all on the same side. They're in front here.
Oh yeah, so you
So
could
the
put
transformation to put fans here, right where our nice USF
Yeah.
sticker is going to go, isn't going to be difficult. We just have to rethink any marketing material that we want to put on here or identification material.
Okay.
So
I'm going to stop
there's
taping
some,
now.
Yeah, there's some learning to be done.
And that's the whole point of this. Thank you very much, Mike. That's a brilliant exposition.
You're welcome. Let's go and
Thanks.
grab something to eat.